Yeah, you bet. We're back here, folks. Hopefully that first section went good on the video lesson for linear inequalities. So what we're going to do today is kind of take a step further into that. We're going to look at what's called a system of linear inequalities. So it's going to be very similar to what we did in earlier chapter 5, where we tried solving systems of equations. We learned about graphing, substitution, elimination. This is going to be very similar to that. It's very similar to section 1, where we solved systems by graphing, but it's going to make use of what we learned last section. So again, a linear inequality is going to be the same thing we saw before, like a linear equation. The only difference is you're going to see the inequality symbols being used instead of an equal symbol. And you're also going to see some of the shading for those different regions, whether it's above or below, based on the less than or greater than. But now a system of linear inequalities is going to be all that, but we're going to have two or possibly more linear inequalities, in one. So this would be an example of what a linear system of linear inequalities looks like. Notice here that I have 3 equations. Okay, more likely the examples we'll give you, there'll be 2 equations, but this is just having 3. All 3 of those inequalities contain the variables x and y. And notice when we graph them, you'll see the lines that we have drawn. So each one is represented here by a line. You'll see the different shaded regions. So you have the blue region shaded here, the red region, and then with the green region as well being shaded. You can see that's shaded above here. So that's kind of what we're going to be doing in this section. Is we're going to be looking at graphing these systems of linear inequalities and trying to identify what is a solution based on the shaded regions that we look at. First example, again, is just understanding what a solution is. So let's say that I give you a point of x and y, and our goal with our system of linear inequalities is to identify what makes a set of x and y actually a solution. So understanding a solution, again, is going to be any values that make the inequality true. So in every point, you're given an x and y. So here I'm given x is 3 and y is 5. So if I want to know if this point is a solution to this system, the system contains 2 inequalities. I have less than 2x and y is greater than or equal to x plus 1. What we're going to do is we're going to take x and y and we are going to substitute them into both these equations. So to show this, I'll use the red for the first equation and blue for the second one. So I'm going to take my value of x and y and plug it in. So I'm going to plug in 5 where y would go, is less than 2 times x, and x in this case is 3. So notice I'm taking the y and x for my point and plugging it in for y and x in my inequality. And now I just want to know, is this true? So what I get is 5 is less than 6. So that is a true statement, so we're good to go on that one. We also have to plug it into the next one. So I have y is greater than or equal to x plus 1. So I'm going to plug in 5 where x goes, 5 where y goes, 3 where x goes, and then my goal is to simplify. So here I would get 5 is greater than or equal to 3 plus 1 is 4. So again, that also makes this true. So because it makes both inequalities true, that means that this point right here would be a solution. All right, so to check the next one, again, every point is a value of x and y, so I have 1 and 4. So my goal is to plug those in and see if I would get a solution or not. So again, I'm going to plug 4 in where y goes and 1 anywhere where x goes. All right, so plugging those 2 things in, what I'd get here, plugged in 4 for y, 1 for x. I got 4 is greater than 0, so that works out. Next one, again, I plugged 4 in for y, 1 in for x. I got 4 is greater than or equal to 4. That one also checks out. Again, this next one, I know that it says 4 is greater than or equal to. So because we have the equal to attached there, that means we have to think, is 4 greater than 4 or is 4 equal to 4? It's got to satisfy one of those. So in this case, just like the previous problem, this would also be a solution. Okay, so a point that would not be a solution is you're going to see one of these points not working out in the inequality. All right, now our goal really today is to try and graph these things. So we talked about graphing in our last section where we had to draw our line based on slope and intercept and then shade above or below. So that's kind of our goal here. Now, the only thing different is we're going to have a system of linear inequalities, meaning we're going to have 2, possibly more equations. The examples we're going to have 2. So we're going to take those two inequalities, and our goal is to graph them. So we are looking again for graphing things in slope-intercept form. This first example we're going to go through is going to be slightly different, but again, you're going to identify the slope and the intercept in each equation to graph. And then remember, we are going to look at whether I'm going to use a dashed line, whether it's less than or greater than, or remember we can have a solid line if it's less than or equal to or greater than or equal to, and then you have the shading above or below based on the inequality. All right, now this first one we have y is less than or equal to 3 and x is greater than 2. So this one's a little bit sassy because we only have y and x, notice, in our equation. So when it says y is less than or equal to 3, okay, this is a special type of line we talked about early on in the year. Okay, there's my y is equals 3 value. So this is going to be a line that is going to be horizontal through that point. Okay, now because it says less than or equal to, that means I'm going to draw a solid line. That is terrible. A solid line through that point. Okay, and then because it says less than, I'm going to shade the region of the graph below that line as best as I can. Okay, now the blue says x is greater than 2. So here's 2 on the x-axis. Now because it says greater than, that means we're going to shade to the right of 2. And because it does not say equal to, the line I'm going to draw is going to be a dashed line. So again, it's dashed because it does not say equal to, and then greater than would be the region of space to the right of the graph. So now when I'm trying to find the solution, because we have two equations, remember, I want to find a point that makes both equations true. So in this case, the region of space that would represent my solution would be the region of space that is highlighted by both lines. Okay, so that would be this region of space right here. I'll try and highlight it in yellow. Any point that would fall into that region of space would be a solution. So again, what we're looking for is just graphing our two lines, shading, and then trying to identify where our spot in our graph would represent a solution. Next one, I have y is less than x plus 2. So here, this one, we actually have slope-intercept form. So remember, there's a 1 in front of my x. So I know that my slope is going to be 1 over 1. My y-intercept is going to be 2. For the blue line, I have my slope is going to be 2. So just know 2 over 1. And then my y-intercept is going to be negative 1. So again, the values in your equation are going to tell you how to graph those. So for the red line, I'm going to start at 2. 1 over 1 means I'm going to go up 1 over 1. Okay, so I'm just going to plot all those points as best as I can. I can go down and left as well by plotting all those points. All right. And then my goal is to graph the line. Now I got to remember, do I draw a solid line or dashed line? Because it says less than and does not contain the equal to, that means that I'm going to draw a dashed line through those points as best I can. And then I'm going to shade the region, in this case, below the line because the inequality says less than. All right, so we got done with the red one. Now what we're going to do is draw the blue line. So the blue line, what we would have is starting at negative 1. Its slope is 2 over 1, means it's going to go up 2 over 1, up 2 over 1, up 2 over 1, continuing on. And I can again go down 2 over 1 like this. Okay, I'm going to try and plot as many points, and then I'm going to draw my line. Because this one says greater than or equal to, that means I'm going to draw this as a solid line, not a dashed line. And then to shade, looking at the blue line, because it says greater than, I'm going to shade above the blue line. So anywhere the blue line is, I'm going to shade everything above. Okay? Now when I shade the blue line, it does not matter where the red line is. I'm going to shade everything above the blue line. But you'll notice that as I do that, there is this region of space right between the two lines here, I'll highlight in yellow, where those two things overlapped. So anything that falls into this point, or into this space, is going to represent a solution to this system. So pretty straightforward about how we're graphing these. Again, just graphing our lines like we normally do, looking at the solid versus dashed line and the shading, and looking for that overlapping region. All right. Next example, again, we're going to have our first one here written in slope-intercept form. What I want you guys to do is let's have you try example C on your own, okay? So I have the 2x minus 3, and I have 1/2 x plus 1. You'll notice y is greater than, and then y is greater than or equal to. So why don't you pause the video right now, try this on your own. Otherwise, I'll have the solution pop up here in just a couple seconds. So go ahead and pause it. Pause it. All right, graphing those two lines, you should get this. In the red line, I started at -3, went up 2/1. Dashed line because it's not equal to, shaded above because it's greater than. Blue line, I started at +1, then I went up 1/2 with my slope. Drew a solid line because it's equal to, and I shaded above because it's greater than. And notice that highlighted in yellow there, that would be our solution. Any point that would fall in that region of space would be a solution. All right, next one, we have something drawn here, or written, sorry, in what's called standard form. So I talked about last class how we could potentially take these two equations and graph them using the cover-up method. Now in this case, using the cover-up method would not probably be the best because when I look closely, I see that 2 and -1, those aren't going to work out nicely. Same here with 2 and 3, not going to work out nicely. So another thing that we can do in graphing these lines is we can simply take these equations and we can write them in the form that we want. So I can write y = mx + b. All right, the only thing I got to do is move some things around. So you'll notice here that I have 2x + y. So if I were to just take this 2x and let's say subtract it to the other side, okay, so I would get y is less than -1 minus 2x. Now I can take that and graph that. It's written in slope-intercept form. Now the only thing is that the way I have it written is a little bit out of order, but notice you have -2 that's with the x and the -1 that's by itself. So just understand that this right here would be my slope and that this -1 here would represent my y-intercept. I can do the same thing with the blue line. I can also take away the 2x and I would get y is greater than 3 minus 2x. And again, written a little bit out of order, but 3 would be my y-intercept and 2 would be my slope. Okay, so I'm going to graph these two lines using what I rewrote. So I'm going to start the first one, the red line, at -1. Again, -1 is my y-intercept. My slope is -2/1, which means I'm going to go down 2, right 1. Okay, so I'm going to plot all those points. I can even go up and left if I wanted to. In this case, I can fit a couple more points on this side, so I'll continue that. Now, because it says less than and does not contain the equal to, I'm going to draw this as a dashed line. And then I'm going to shade, because it says less than, I'm going to shade below the line. Okay, so again, I just rewrote that equation so it's in slope-intercept form, even though it wasn't in the correct order. And I can graph it there. Do the same thing with the blue line. I'm going to start here at +3. I'm going to go down 2 and over 1, down 2 and over 1. I'm going to continue that trend all the way through on the right side and the left side of my graph. Now this one again says greater than does not contain the equal to, so I'm going to draw a dashed line. Pausing for a second here, you will notice that those two lines are parallel to each other. So that's something we talked about in section 4, that if we see two lines parallel to each other, that would represent no solution. However, when it comes to an inequality, what we are looking for more so is the shaded regions. Remember, it's a point that lies in the shaded regions of the two lines. That's going to be our solution. So when I shade this, it says here greater than. So that means I am going to shade above. So you'll notice that when I shade my two regions in, not only are the lines parallel, but you'll recognize that my shaded regions do not overlap. So if your shaded regions do not overlap, what that means in this case is that there is no solution to this problem, okay? So that means there is no point that the two shaded regions have in common because they don't overlap. So this is a special case that we talked about in section 4 that you still can see. All right, last one. This is kind of a little bit of a challenge in terms of your understanding of linear inequalities as well as systems of linear inequalities. I want to see now if we can work backwards. Given the graph, can we write the equations within our system, or sorry, the inequalities within our system? So this first one, I have two lines here. I have the solid line going across. I have the dashed line going here, okay? Shaded region is here. So I'm going to start first by looking at, let's just do the horizontal line, okay? So horizontal line is kind of like we did in our first example here. Notice it goes through the point right there of -2, all right? So I'm going to write this as y. Now what we got to think about is my inequality symbol. Do I use less than? less than or equal to, greater than or equal to. So the dead giveaways, notice that I'm shading above this line. So I know that I am at least going to use greater than. Okay? Whether it's greater than versus greater than or equal to will depend on the line itself. So notice it's a solid line. Because it's a solid line, I know that I have to have greater than or equal to. So my first equation would be y is greater than or equal to negative 2. Now my second equation, I'm going to follow the same idea, but now this one is actually forming a line at an angle, so that means it's going to have some slope to it. All right, so where does it start? Notice it starts right here in the middle, so I know it's going to be plus 0. I'll just write that 0. Okay, then the slope, how is it going up and over? What's the rise and the run? So notice from this point 0, my next point would be right here. So notice it's going up 1 over 1. So my slope for this line is going to be 1. So I'm going to write 1x plus 0. Give myself a little room there. So 1x plus 0. And now what I got to do to finish this off is think about what inequality symbol would I use. So notice I have here the shaded region is below this line. So if it's below, that means I'm going to use the inequality symbol less than. And then you will also recognize that it's a dashed line. So the question is, would I use less than or equal to? Now because it's a dashed line, I'm going to use the less than and not include the equal to. So that means my system of equations would contain these two, my system of inequalities would contain these two inequalities. Y is greater than or equal to negative 2, and y is less than 1x plus 0, or just simply 1x. All right, try this next example B on your own. Here you have a vertical line and then a line similar to what we did in A. So go ahead and try this one on your own. All right, so what you should get is x is less than or equal to 3. Again, that's from the vertical line going through 3. Shaded regions on the left, which means less than, and it's a solid line, so we include the equal to. For this one, it's going up and to the right, so it starts at negative 1, so that would be my y-intercept. And then it goes up 2 over 3 for the slope, so I wrote 2 over 3x. And because it's shaded above, I know it's greater than, and because of the dashed line, it's not equal to, so just greater than. So again, this would be my system of linear inequalities. Okay, so again, system of linear inequalities is just containing two or more inequalities that have x and y. Our goal is to try and find a solution by graphing both, shading, and figuring out where the shaded regions intersect or overlap, So again, if you have any questions on this section, make sure you jot them down, post them on the comments part of it, and then again, work on those practice problems on big ideas. We'll see you guys next chapter. Enjoy your spring break. Peace.